is operations on functions and compositions of functions. Now the operations is what we're starting with. Okay. Now, although the notation's a little weird, don't read too much into that because it's actually quite simple. So with addition, you're either going to have, we've done this notation before, so the f of x plus g of x, that just means to add function x to function g. It can also be written like this, so it's the same thing. So you might have two different functions. For example, over here, if f of x is 3x and g of x is 2x minus 4, if you add the two together, you just add this like term and this like term together. And simplify. Now, sometimes you might be plugging in a number after that, but most of the time you're just going to be combining functions. So subtracting again, you would just subtract the two functions. So the f function minus the g function. Only thing with subtraction is you will have to distribute that minus sign if it's there. So just be aware of that, and then combine like terms. So that one would come out to x plus 4 after distributing the negative. Multiplication. If they're two binomials, that may involve some FOILing, so just be aware of that. When you're multiplying one function times the other, so in this case we distribute the 3x. Dividing, so usually just straight up division, you just put the numerator over the denominator, and you're not really gonna fall into too much simplification, but you do need to list where the denominator would be undefined, which we did before break. All right, so on this one, I'll just zoom in a little bit because it's small. If it was f divided by g, so that would be the f function on the top, g function on the bottom. But if you set the bottom equal to 0, that will tell you where your restriction on the domain is. So for the x is not equal negative, or x is not equal 2, that's if you set that denominator equal to 0, and it'll solve for x. If you need to, you can factor it first. So if you divide by 2, that's where that number comes from. So x could not equal 2 because that would make the denominator equal 0. We will be graphing. Well, actually, you guys have already graphed some of these before. That's when we were factoring a bunch of them. That would be excluded values, stuff like that. So that would be where an asymptote would be in this case. Okay. So you do have to, if it's division only, you would have to identify what value of x would equal 0. Okay. And then restrict that from the domain. Okay. So we're going to get into those. So the domains of the sum, difference, product, and quotient consist of the x values that are in the domains of both f and g. The domain of the quotient function does not contain any x value for which g of x equals 0, or whatever function's on the bottom. Okay. So we're just going to start off doing some operations here. So if you see f plus g of x, that's the same thing as the f function plus the g function. So the f function would be the negative x squared, it's right here, plus 3x plus 1, added to the g function, 2x squared minus 5. Now with addition, the parentheses are optional because they're not going to affect anything. Subtraction or multiplication, those are required. So on addition, you can just combine like terms. So negative x squared and 2x squared would be what? 1x squared. 3x has no like term, so that's going to be tacked on. And then we have positive 1 and negative 5. Negative 4. That's your answer. Okay. So with function operations, you were just doing the operation and combining the functions. Okay. So subtracting. Now keep in mind, it might always be f first and then g. It might be the g function plus the f function or g minus f. So pay attention to the order that it's written. On this one with subtraction, the f function minus the g function. So the only thing that's going to change here is that's going to be a minus sign in between the two, which you will need to distribute to the g function. So you'll have negative x squared plus 3x plus 1 minus the g function, 2x squared minus 5. So on this one, the parentheses are absolutely necessary. You will distribute that minus sign prior to combining like terms. Okay, so be careful with that. This stays the same. Now it would be minus 2x squared plus 5. Then you would combine like terms after that. So can anyone tell me what that looks like? Braxton? You have 3x squared plus 3x plus 6. Okay, after combining like terms. So with addition, parentheses are not necessary, but they don't hurt anything. Subtraction, they are necessary. But pay attention to the order of these. So these examples, I had F first on all of them. It might be G. You might have 4 different functions. You might have F, G, H, and I, and you have to do different operations with those. Okay? So pay attention to the order. Questions before we move on? Now, multiplying. You do need parentheses. So we have 4x squared minus 2x plus 3 times the G function, negative x plus 5. Now this is a trinomial and a binomial. It's technically similar concept to FOIL. It's just not technically called FOIL. Distribution. Okay. So first you will distribute the 4x squared to both. What will that give us? Just those two. You have 4x cubed. And 20x squared. Alright, distributing the negative 2x to both. Negative 2x times the negative 1x is a positive 2x squared. Negative 2x plus 5 is negative 10x. And then distributing the 3. 3 times negative x, negative 3x. 3 times 5 is 15. Then you would combine like terms. So, we're always going descending order, per usual. The negative 4x cubed has no like terms, so just write that first. We're going to combine these two and these two. So, what's your answer? Okay. So 20 plus 2 would be 22. Negative 10 minus 3, negative 13. Okay. Not too bad? Yeah. Okay. Now f divided by g, write f in the numerator, g in the denominator. And there's one other thing we have to do. So we have 4x squared minus 2x plus 3 over negative x plus 5. Okay. Now you also need to include the value of x in the denominator that would make that equal to 0, because we have to not include that in our domain. So if you can't do that in your head, off to the side somewhere, set this equal to 0 and isolate x. You would subtract 5, negative x equals negative 5. Divide by negative 1, that would be 5. So you would tack that onto your answer. X cannot equal 5, because that would make the denominator equal 0. So on the division ones, you really don't have to simplify it at all. It's just numerator over denominator, but figure out which value of the denominator would make that equal 0. So you do have to include that. Okay. Questions, because we're about to change gears. So everybody understand function operations? Again, pay attention to the order, because G might be first sometimes. It's not always F. Okay. Any questions? All right, now composite functions. So this goes with what we're doing on the back, but before we get there, I want to point out what we're doing. That's too far. So composite functions or compositions of functions. So that is when you combine two functions by putting one function's result inside of another function. Okay. Now it can be written any of these ways. Okay. So this little O right here symbol, that's of. Okay. So this is read f of g of x, which is also read as f of g of x. Now, in my opinion, these notations are a little bit easier to understand, but your book does both. So I want you to get used to seeing both. What that means Okay, and you work from the inside outward when we do these, and we're going to do several on the back. Okay. You're always going to do the inside first. So you're going to simplify what's on the inside. So you would find your, for instance, on this first one, g of x function. You would plug that function in where x is in the f function. Okay. Now, eventually we'll get to numbers and stuff like that, but we're going to start off with just compositions of functions. So if it's given to you like this, I would actually write it like this because it makes it a little bit easier, especially for those of you that are extremely visual, which are 75% of you. Okay. So these are just all examples, but those are read as f of g of x, g of f of x, f of h of x, h of f of x, h of g of x, any letter, okay, whatever the functions are. But you're plugging one function inside of another instead of just combining them like we were just doing. Now, do not confuse this open circle with multiplication, like we did in C. That is a closed dot. This is open. Okay. Questions? All right. So, given function f is 2x minus 5, function g is 3x, we're going to find f of g of x and g of f of x. So, we're finding two of them. Okay. Now, so I'll help you especially with this first one. So find f of g of x, okay? And then separately we're going to find over here g of f of x. They are completely separate. Okay, so this is like two problems in one. Now, again, easier way to write this, in my opinion, so if you're given this in your homework, you can write it down in your homework in the other notation. So f of g of x like this. That is easier to look at because we're going to start plugging stuff in. So these two are the exact same thing, just written different notations. Okay. Now you're going to start inside and work your way out. So what's the g of x function since that's the furthest in? 3x. I want you to substitute that in where g of x is here. Okay, so the 3x is going to replace g of x here. Okay. So this became that because it is that. Everyone with me so far? Yeah. So now I'm working with f of 3x. What that means, okay, plug 3x into the f function. Now that is wherever there is an x. So I'm going to put it right here. So 3x is going to go right there. Now I'm going to use different colors just so you guys can see that. So the f function is 2x minus 5, but instead of the x, the 3x is going to take its place. So I put g of x into my f function. That's what I did. And now we simplify. So what is 2 times 3x? 6x. And then minus 5. That's as simple as we can get. Now we're starting off basic. They will get a little bit tougher as we go through the notes, but it's the same concept. Okay. Now if we reverse the order, okay. Again, now f would be the furthest in, so I'm going to rewrite this again. I think it's a little bit easier to look at like this, because then you can start inside and work your way out, which is what you will do either way. But the first notation can be confusing for some people. So the f of x function is 2x minus 5. So that will take the place of f of x in here. Okay. So f of x is that. Okay. Where is that going? Into the g function right here. So it's going to replace the x variable in whatever function it's going into. So that would be 3 times 2x minus 5. So this is the 3x function, but x has been replaced by the f function. Okay. And then you would distribute the 3 to get what? 6x minus 15. So these were very basic. Are there any questions? Okay. So again, I would write it in this notation, because then you replace the inside function with its function, plug that function into the one on the outside. Okay? Yes.
So, use all the, like for example on gx, you just substitute the gx inside the x.
Right, so since g of x equals this, it takes its place. This goes into the f function where the x is. Okay. Anything else? And it does depend on the order which is written. So if g is first, that's furthest outside. So just be aware of that. Alright, we're going to do the same thing, but you'll notice that this one's got an x cubed, so that's going to change things a little bit. The process does not change at all. So we're going to start out, we are doing both, so just be aware of that. Okay. So starting out with f of g of x, which I'm just going to go ahead and write as f of g of x, like this. Alright, so that's what I mean. If this is the problem in your book, I would recommend you write it like that. Okay. Now the g of x function is what?
2x cubed minus x.
So that took the place of g of x because they are equal. Okay. Now where is the g of x function going? It's going into the f function. So we're plugging this in here now, wherever there's an x. Now that negative sign goes out front, so use parentheses. So negative 2x cubed minus x plus 1. So this is where that x was. So it's negative x plus 1. Okay, stay organized as you do. You do need to distribute that minus sign in here, and then we'll combine any like terms we have. So after we distribute minus sign, what do we have?
Negative 2x cubed plus x plus 1.
Are there any like terms? No, so you know. Okay. So this one wasn't too complicated. Okay. Does anyone have any questions at all? Okay. If we reverse the order, g of f of x. We're plugging function f into function g. So f, so this would be g of negative x plus 1. Oops. Okay. Now that's going to be plugged into function g. However, there are two different x's in function g. Okay. So we are plugging it in here and here. So you have to put it in both. Everywhere there's an x, you have to put whatever that function is. So that would give us 2 x cubed minus the same function. So everywhere there's an x, you put that other function. Questions before we keep going? Now, a binomial cubed is going to take a minute. I'm actually going to do it off to the side. Okay. Negative x plus 1 cubed means 3 of those binomials. It means negative x plus 1 times negative x plus 1 times negative x plus 1. So if this comes up, you will have to distribute these. Now you can't do them all at once, so you would pick 2 to FOIL. And it doesn't matter which 2, they're all the same anyway. Okay. Now to save time, I will assist you in foiling. Okay, so I'm going to FOIL these 2 first. So again, this is kind of its own little thing off to the side, but this will take the place of this. You will have to do it anyway. So either keep working down, but depending on how large you write, you may not have room. So, that would be an x squared minus 2x plus 1. Okay. If you FOIL that out, that is what you should get. Okay, after combining like terms. I've just been doing long enough, I can do it in my head. Okay. Again, we did this on the front when we were multiplying, so you have to distribute those two. So that'd be negative x cubed plus x squared. Then distribute the negative 2x. Positive 2x squared minus 2x. And then distributing the 1 minus x plus 1. Okay. So now back over here, we'll have 2 times all of that. What does that simplify to when you combine these two and these two? Minus 3x plus 1 minus negative x. This is about as tough as they get. So we can handle these ones. The ones we did previously should not be very difficult. Now you'll need to distribute this 2 into here and this minus sign over here. So I just saved that. If you wanted to do it first, that's fine. So that would give us negative 2x cubed plus 6x squared minus 6x plus 2 plus x minus 1. And we combine like terms one more time. Anyone tell me what the result is? Negative 2x cubed plus 6x squared. We have negative 6 and then a 1x, so negative 5x, and then 2 minus 1 is 1. So if they're nonlinears, meaning x squared, x cubed, they may take a little bit longer. It just depends on the operation you're being asked to do. That's about as tough as they get. Okay. Each individual step is not difficult, but keeping organized is for some of you. So the last couple are similar but different. So is there any questions on example 3 or 4? Okay. Now these ones, what's different? There's a 2. Okay, instead of an x. So, rewrite this in the other notation because it's a little bit easier to look at. So f of g of 2 for this one. If you want to go ahead and write this one, this will be g of f of 2. Now, inside g of 2, that means plug 2 into the g function where x is. Okay. Now the g function is right here. So you approach these a little bit different. So we have f into, well, g of 2. So I'm going to plug 2 in here and 2 in here. 2 squared plus 2 minus 1. So just instead of x, you put the 2 where the x was. Now I'm going to simplify that down to one number. What's 2 squared? Plus 2. Minus 1. 5. Now what do you think you're going to do? Put 5 into the f function. Okay. That is right here. So that would be 5 plus 3, which is 8. So if there's x's still, you are just plugging one function into the other, simplifying it down as much as you can. If it's a number, plug the first number you start with into the inside function, simplify it. Whatever that number is, you plug into the outside function. I want you to try F. Okay. So you're going to plug 2 into the F function, get that result, plug that result into the G function. Okay. Try it. There's only one number it could be, so this will tell me if we're getting it or not. Again, plug 2 into the F function, simplify that result into the G function, simplify down to one number. Anyone have a result? Okay. 29. Anyone have anything different? It should be 29, so that's good. Okay. All right, let's say we did not get 29. Make sure you're paying attention. So we're plugging in 2 into the F function inside here, so stay organized. F function is x plus 3. So 2 takes the place of x, and then plus 3. Okay, so that would be G of 5. Okay. 5 goes into the G function everywhere there's an x. Now that is multiple places, so just stay organized with that. So that would be 5 squared. Now as a side note, if you're plugging into a square and it's negative, make sure to use parentheses, because you should be squaring the negative also, if that comes up. So parentheses will not hurt anything, even if you don't need them. 5 squared is 25, plus 5 is 30, minus 1 is 29. So with these ones, you have to do plugging back in multiple times, but it's actually easier because there shouldn't be any foiling involved, stuff like that, so they're different. Okay. All right, last two are very similar, but I went ahead and typed it in the notation. So sometimes you're given the notation with the little o, sometimes you're given it like this. They're the same either way. So this means I'm doing what first? Plugging -3 into the x function. Okay. So that would be -3 in parentheses squared, because it's the whole value squared. So what's -3 times -3? Positive 9. Okay. Make sure to square the whole thing. And then I'm putting 9 into the f function, which is x minus 5. 9 minus 5. 4. So f of g of -3 is 4. Okay. Try the last one. Just reversed it. Your question? Yes. And then wherever that result is, you plug into the G function. So start inside and work your way out. Okay. So take care of the inside function, then plug that result into the outside function. Anyone have an answer yet?
64.
It should be 64. Yes. Okay. So the f function, -3 into there. So that would be g of -3 minus 5. Which is -8. That goes into the g function, but you have to square the negative also. So it's -8 squared, which is positive 64. If you got -64, you need to put parentheses. Okay. How are you feeling? Not as hard as it looked on the paper, hopefully. Okay. Now again, biggest mistake I see on these, we started with operations, adding, subtracting, multiplying, dividing. The open circle on composition is not the same thing as multiplying. Okay, composition functions plug something into something else. Multiplying we did on C is just multiplying. Okay? So any questions about that? Alright, yeah.
For the division, do we actually divide them or we just find what x is in?
You would just, if they can be simplified, you can factor them and check. They shouldn't really be factorable.
But
Like to
x
check.
doesn't equal, that's just like our answer?
That has to be included in your answer, yes.
Oh, but we divide it.
You don't have to do anything with this. So my answer on this one is all of that. So versus multiplying, we had to get rid of the parentheses by FOILing it out. Dividing, you just leave it alone. Unless it's like 3x over 6x, then reduce it. But okay. So your homework is not very long.